Welcome to myprojectbazaar.com. Now we are going to discuss about the product Multichannel Decoded Local Binary Pattern for Content-Based Image Retrieval. Now we are going to discuss about the overall abstract for the process. Local binary pattern, that is the LBP, is widely adapted for efficient image feature descriptions and simplicity. To describe the color image, it is required to combine the LBPs from each channels of the image. The color image consists of three bands, that is the red, green, blue. So we have to take the LBP features from each bands. The traditional way of binary combination is to simply concatenate the LBP from each channels. After getting the feature from the red, green, blue channel, we have to concatenate the both together to form a single features. In order to cope with this problem, this paper proposes a novel method for image descriptions with multi-channel decoded LBPs. We introduce an adder and the decoder process along with the LBP for the combination of LBPs from more than one channels. In the adder and decoder process, the combination of red, green, blue channels will be combined together as an test features. Image retrieval experiments are performed to observe the effectiveness of the proposed approaches or compared with the existing ways of multi-channel techniques. The experiments are performed over the 12 benchmark circuits, that is the 12 benchmarks databases such as the Coral and others, etc. It is observed that the introduction of the multi-channel adder and decoder based LBPs significantly improve the retrieval performance over the database. Hence, the process is well efficient by the combination of effective LBP and the classification using KNN. Now we discuss the overall flow diagram for the process. At first, the input image is taken from the dataset. After getting the dataset image from the dataset, the input image is undergone for the pre-processing. In the pre-processing, we have to consider the noise filtering. The noise filtering is done by using the Gaussian filter. After the filtering is applied, the channel separation is carried out. In the input image, the color image is present. So the color image consists of three bands. The first band is red channel, and the second band is green channel, and the third band is blue channel. After segregating the each band from the image, the feature extraction is carried out. The feature extraction is done by using the local binary patterns, that is known as the LBP. After extracting the feature points, that is the feature patterns from the image, the respected feature is stored as a test feature. Then the test feature is classifying with the train feature using the KNN classifier. By using the KNN classifier, the distance matrix are well efficient. Then after the classification, the estimation is carried out. In the estimation part, we have to consider these parameters: accuracy, sensitivity, specificity, then the PPV. The PPV indicate the positive predictive value, and the NPV. Then the NPV represent the negative predictive value, and the time estimation of the process. The time estimation will provide the overall execution time for the process. Now we discuss the initial running procedure for the process. Now open the MATLAB 2013 and change the current directory as in the code. If you want to execute the code, means you can see the main underscore GUI.m file in the current directory. Right click in that file and select the option Run. Now the initial GUI design was opened. In that you can see the several push buttons in the left side and 2 axes for the display purpose in the right side. Now click the button Import Image. After clicking the button Import Image, you can see the dataset folder. In the dataset folder you can see the some of the test input. Now select any one image from the test, and those selected image is shown in the axis 1 with the title Input Image. After getting the input image from the dataset, the pre-processing is carried out. After applying the pre-processing, the filtering is applied for the input image. Then the filtered image is shown in the axis 2 with the title Filtered Image. Then click the button Channel Separation. After clicking the button Channel Separation, the Channel Separation GUI design was opened. In that we can separate the red, green, blue channel from the single RGB image. Now click the first check button Red Channel Separation. Now the red channel separated image is shown in the axis 1. Then click the second check button Green Channel Separation. Now the green channel image is shown in the axis 2. Now click the blue channel separation checkbox. Now the separated blue channel will shown in the axis 3. Now in the main GUI design, click the button Feature Extraction. Now the Feature Extraction window was opened. Now click the radio button Feature Extraction. Now the LBP feature is taken from the test image and those features are stored, then the shown in the table. Now click the button Classification. Now the classification result will show the similar images as well as the retrieval also combined with the classification. Now the retrieved image is shown in the figure 100. Now the subplotted shows the similar images which is matched in the database. Now click the button Estimation. After clicking the button Estimation, the accuracy, sensitivity, specificity, then PPV, that is the positive predictive value, on the NPV, then the negative prediction value, then the calculated error rate, then the calculated time is estimated, as well as the accuracy, sensitivity, specificity, positive predictive value, then negative predictive value, then error rate calculation is shown in the bar chart format. Thanks for watching this video.